Hello guys, so my name is John. You can call me Zhuoran as well. I'm a front-end team lead at Endowus. So we cover most of the client-facing products, including a React web app and some Node.js app server. And also recently we added Flutter to our mobile stack. But today I'm going to cover my journey and the experience with the Dart and the Flutter from a front-end engineer's perspective. And I hope we can give you some confidence if you are looking to pick up Flutter with your front-end background. So first of all, I want to give a background about our company. We are Endowus, the only Singapore financial technology company that can manage people's CPF money. We are licensed by MAS, and we provide institutional quality financial products at the lowest cost possible. So the reason why we pick up Flutter is that in late 2019, we did some research. We plan to do a mobile app. We checked out native development and React Native and also Flutter. The reason why we eventually pick up Flutter is that Flutter gave us a hybrid solution, so which is very cost efficient for startups, and you only need to write the code once, but deploy it to both iOS and Android with a native performance. So native performance is very important here. And also our designer and product manager are okay to have a consistent design tune across iOS and Android. So we don't have many platform-specific UIs. And the last thing is that we checked out Flutter. It was in stable release and it's constantly evolving. There are more and more libraries within the ecosystem and more active contributors. So we are confident to choose Flutter as a solution for our mobile app. So before I kick off on the technology part, the theoretical part, I want to give you some previews of what we have been building. So this is just a few screens. We definitely build more, but I want to give you a sense of how the animation can be done within Flutter and how smooth the scrolling is, the complicated animation is. So this is this thanks to the power of Flutter. So we achieved it in just 2 months. And before that, I also want to talk about some of my background so that you can have some comparison and a contrast to yourself. So you probably will gain a lot of confidence. So you can know that, oh, you can also pick up Flutter in a short period of time. So I started as a full stack or backend developer in a US bank. I was working in equity research team, mostly on Java and Slang, which is a domain-specific language. The programming styles was mostly OOP in Java and FP in Slang. So then I joined a startup. Most of my work was on React and Redux with JavaScript and Node.js. Then later on, I joined some companies and then landed at Endowus. So I picked up TypeScript, and also we have a lot of usage of Redux Saga as well. And sometimes I do Python to write some utility scripts. So I do have some hybrid experience with the React Native in my previous job, which is about 5 months in production. So, but overall, I have very limited knowledge about native development when I started Flutter. So the first thing I want to share is about the UI system. So today I want to give you some information about how some React or web development knowledge can be transferred to Flutter development. So the first thing is about a component and a widget. The most common thing between these two is that they are all declarative. I think it's a trend for client-facing application development. So you focus more on how to configure your UI. You don't focus on the painting part. You let the rendering engine handle it for you. So in React, we call it component. In Flutter, we call it widget. And in iOS, they introduced the Swift UI, which is actually also encouraged by this kind of reactive development pattern for UI, I believe. So as I said, for component and a widget, you focus more on the configuration part over the painting result. And eventually, your component in React or your widget in Flutter will be translated to some fundamental elements that will be painted in the rendering engine. So for React, eventually it will become a DOM tree, as you can see in the left side. And for Flutter, eventually it will be a render object from the widget to element that render object in the Flutter engine. So this concept is pretty similar across these two frameworks, or I'll say development in the development experience. So I was pretty comfortable to pick up Flutter to develop the widget there. And every render object in Flutter has a unique ID. You can use it to locate your widget. You can use it to observe whether your widget has been re-rendered, has been destroyed. And the next thing is something slightly different between React and Flutter, is that in React, because it controls manipulate the DOM, and HTML DOM, updating it is quite expensive. So in React, they implement something called React Fiber. It's a heuristic algorithm to compile virtual DOM. So within the virtual DOM, within React, they do certain thing called reconciliation. So they compile what should be updated in the actual DOM, and then they only update the part that need to be updated to improve the performance. And there is also a concept called virtual tree and native tree for React Native for mobile, a similar concept. But Flutter is slightly different. There's no concept of virtual DOM. So I will use these two graphs to illustrate why Flutter is such a powerful framework. So as you can tell, in React Native or React, there is a, let's talk about React Native only here. So for React Native, there is an OEM widget provided within the iOS or Android ecosystem in the platform itself, in the SDK. But React Native, to control that, they have to implement a bridge layer, which is in the middle between JavaScript and the OEM widget. So basically, your JavaScript code manipulates the OEM widget within your native platform through this bridge. There is some communication overhead. That's one of the reasons why animation once was a challenge topic for React Native. And for Flutter, as you can tell, it takes over the canvas from the platform, and everything that is within your render engine inside your Flutter app. So one benefit of that is you don't care about backward compatibility, because you know regardless is iOS 11 or iOS 12 or iOS 13, as long as it can run the Flutter engine, you can render your widgets properly because you don't rely on any OEM widgets. But one concern people has raised is that, oh, what if iOS implement a new widget or new look and feel of the UI? How soon will Flutter be able to adopt it? I think we should be confident because the community is getting bigger. And I believe Google is investing heavily into this framework, so they should be able to adopt the new UIs quickly into Flutter in the widget, in the native widget. But only time will tell. So let's see. And this graph, these pictures demonstrates the difference of the virtual DOM part. So Flutter, as you can tell, there is no bridge layer, no virtual DOM inside of the rendering process. So the painting anything on canvas is absolutely controlled within your app. That's why it's powerful, and the animation is constantly 60 FPS most of the time. And regarding the reconciliation I talked about, inside the React, there is a heuristic algorithm, as I mentioned, which is an ON algorithm to compare the difference of the widget, of the components, whether you should re-render or not. So the first thing is that the two element types should produce different trees. So basically, they check the instance types, whether the instances are the same or not. If the instances are different, everything in the subtree will be destroyed and will be repainted from the DOM or from the native widget. And the second thing is that in React, we have a concept called a key prop. For example, if you have a list of atoms, you are sorting the list, and if you have a key, then React will know, oh, the order of the atom has changed because they find out the sequence of the key has changed. So if you check out the Flutter source code of the widget, there is a function called can update. So it exactly implements what React reconciliation documentation was talking about. Firstly, you compare whether the runtime of the old and new widget tree are equals, and then you check the key. So I believe Flutter has a lot of inspiration or got a lot of encouragement from how React implement this reconciliation process. And next thing that is similar across React and Flutter is life cycle. So they have this concept called life cycle, but the exact life cycles are slightly different. I would tell some of my personal opinions about them. So first of all, in React, if we don't think about functional components in React, if you only talk about class components in React, they have stateless component and stateful component, which is exactly the same as Flutter. As the name can tell, stateful component means you can maintain some local state. and you can mutate your local state. Every time when your local state is mutated, the render function in React will be triggered. The build function in Flutter widget will be triggered. And also we have some comparison life cycles in React, like should component update. We have update life cycles like component did update, component will unmount. There are something similar in Flutter, like did change dependencies, mounted and dispose, deactivate, also initial state. So one thing I want to highlight is that in Flutter, there's some function, there's a method called add poster frame callback. This is not part of the lifecycle of Flutter. However, it's very handy and useful in your day-to-day development because for Flutter, once you are rendering a widget, you cannot mutate the state. In React, it's not encouraged to set state in component did update lifecycle, but somehow in React, you can still do it. Although it will give you a warning, but you can still do it. But in Flutter, if you do it, you will get a systematic error, say mark layout needed. It's not available during the build process, something like that, because when you are rendering your widget, Flutter does not allow you to update the widget or mark the widget dirty again. So that's why you have this add poster frame callback, which will be called exactly after every frame is painted on your screen. So you can use to achieve something that was available in component did mount from React. So the next thing I want to share is my opinion about how to determine whether a widget should be repainted in Flutter. So in React, there is something called should component update lifecycle. So in this should component update lifecycle, we can explicitly take over of the re-rendering logic. So we can say, oh, if this parameter doesn't change, then we don't re-render. If this parameter changes, then we re-render. However, in Flutter, I saw some guy asked for this feature in GitHub in 2018, but there's no following discussion. So I guess it's not on the roadmap yet. And I guess the underlying development is also a little bit different. The implementation is slightly different. So I'm not sure whether this will be feasible for us to use in the near future. So how do I control whether a component will be rebuilt or not in Flutter? Most of the times, in my limited experiences so far, most of the time you don't have to control that. But if you really have to, you can use things like mark needs layout, mark needs build, mark needs paint to mark the relayout boundary that will be repainted or not. So relayout boundary is like a boundary to tell the rendering system, oh, if I'm going to repaint this widget, where should I start? So you can do that. And also in provider of Flutter, you have something that is very similar to the selector concept in Redux, in React. So selector, basically, you can memorize parameters. If your parameter doesn't change, then you get the same instance of the object. So you don't trigger any re-render if you use selector with provider. And the next thing is that you can always make your widget constant. So if you declare constant in front of your widget, it means it will always use the same instance, even if it was rebuilt. So these are some ways I have found so far to explicitly control whether to rebuild your Flutter widget or not. So hopefully in the near future, we have some better ways like should the component update in React lifecycle, which we can explicitly control that easily. And the last thing I want to share is that this is very transferable from web development to Flutter. It's a layout system. In web, we use CSS. In React Native, we also use something similar. We use Flexbox. We have media query. We can place elements on an absolute position on your canvas with a position absolute. And we can also rotate your elements. We can have some transformation with animations like keyframes, declare a curve, declare a twin, declare an animation interval. So all these things are replicated or have something similar, compatible, interchangeable within Flutter. Like Flutter also has the Flexbox system, has the stack, which is a replication of position absolute, similar thing, and has the transform, which can rotate your elements and adjust the metrics of your elements on the canvas. You can also declare animations with the twin as well. So this is a table I summarized for you to quickly understand like the unit in layout system of Flutter and web, and also some common elements from HTML and Flutter. So I found it was pretty a smooth transition for me from web word to Flutter because of this mapping. So for example, for media query, you have exactly similar concept. For web, you can say, oh, if the screen is larger, I want to display them in line, like this first name and last name input box. But if the screen is narrowed, I want to stack them together in vertical line. So this is also achievable with Flutter because it has a media query. It's just that Flutter has this concept called dependency injection. So every time when you want to access something from the widget tree, you have to use media query.auth. Basically, it means I will look up from this context and find out the nearest media query instance. That's how you access a media query. So Linux once said talk is cheap. So we have been talking about the theoretical stuff for almost 15 minutes. So I want to give you a live coding demo to illustrate how easy it is or how smooth it was to transfer from web development to Flutter. So I'm going to do a very quick demo of the layout system and the animation for the world of web. So I have this HTML DOM, which, as you can tell, there are 3 stars and there's a programmer. So now I'm going to make something for us to replicate in Flutter as well. So first of all, I want to declare this one as a flex item. So I want to align my items from flex end. So you can tell my stars will be moved to this one. And I want to say flex direction. I will say column. So it will align them in vertical lines. And then I need to give a explicitly height 400 pixel, and I give a width of 200 pixel. So now I get it. And the flex direction, align items flex end. So now I have to have this flex box. So everyone occupy one base element from the flex. Okay, oh, sorry, I have a typo here. That's why it was not vertical. And now let's give a background color. I will use the branding color of our company. And yeah, so now let's change the font size to a bigger one, which is 3 rem. Okay, so now I want to place this hiker and place this programmer at the bottom. So I just say position absolute and the bottom 0 and the right 0. So it should flow to the bottom right corner here, but it's too small. So let's increase the font size. I will say this one. Yeah, so now you have this layout, and now let's quickly animate them. So to save time, I have something that is already written. I just copy paste here. So now I declare an animation. As you can tell, it's a range from rotate 0 degree to 360 degree. And now let's declare the animation. I say my move, and I give a interval 2 seconds, and I say infinite. It means the animation, it will repeat itself. So it starts to move. And now I want to give a curve. I say linear. If linear, it should rotate in a constant speed. But if I say ease in and out, it should have some nice bouncing or ease event like a curve within that. So now we have a sense of how HTML organizes the layout and animation. Let's do the same thing in Flutter. Let's achieve exactly the same thing we want to do in Flutter. So first of all, I have a ready to use Flutter app here, which has a star. So first of all, I'm going to wrap it on a stack. So stack is an open space where you can flexibly place your elements. So first of all, and I place them here. And now what if I want to have a column? Because as I said, it's also using the Flexbox system. So you can do something exact similar. So now I want to give a background of it. Just say colors.blue. And now I'm going to give a cross elements column.blue. And I want to have a width with 200 and a height should be 400, exactly the same as just now. And then now, because I have this cross align element, which is same as align items in HTML, So I will say cross elements.end. As you can tell, the stars moved to the end. What if I want to give the equal space of them? So I will give them this flexible widget. I'll just copy paste them here.
Yeah.
And
hey,
now, yeah.
Sorry for the interruption. Could you make your font a little bit bigger? I think we have requests that it's hard to see.
Sorry, the font or the voice?
No, the fonts.
Okay, yeah. Cool.
I think it's great.
Great. Okay, cool. Sorry about it. And now we have this. So as you can tell, it's still not expanding to occupy the equal space. So what happened is that we have to give it a fit. Flex fit pet. And now it should occupy the space, and you can also give the weight of it. So let's copy paste them. Now you have it expanded. So in Flutter, for your convenience, there is a shorthand, which is called expand, can achieve exactly the same thing as what we did. Okay, so now we have this layout, and lastly, I want to have an absolute position of this hiker as just now where we have this hiker on the bottom right corner. So I will do something similar. Bottom 0, right 0, and the child, I'll say text. I'll give a programmer there, and now I can declare a style to make it bigger. Font size, let's say 100. Yeah, now we achieve it. So the next thing is about animation. So I will firstly transform it to a stateful widget. I never use my mouse, so I just say convert to stateful widget. My IDE will give it to me, thanks to the powerful Flutter IDE integration. And then I will mix in it with something called the single tick provider state mixing. This is necessary if you want to achieve your animation, and I can override the init state function. So now I have the state. The reason why I have this is that I want to instantiate the animation controller so that I can start to animate my widget. So I declare an animation controller, I give a duration, I say seconds, 2 seconds, and you have to pass a waythink. So this is why we need a mix in of single tick provider, because waythink is the way of how your screen scan the tube. That's how it works for a monitor. You can check out more online. Now I have this animation controller, and now I want to declare a curve so that my animation will work within certain curves. So I have some code prepared to save our time. I'll just copy and paste it. So now I declare a curve. And this curve, as you can tell, is an in and out curve, which is built in from Flutter, exactly the same as this web curve. And now I have a twin. So twin is like a scaling of the value based on your animation controller. So it will have a range from 0 degree to 360 degree. And I need to declare the local value of it. So now we have everything we need for animation. I will transform this widget to an animated widget. One way you can do it is to use an animated builder widget. And you can have a child. The next thing I want to do is to have a builder. I will declare a builder, and the first is context. The next one is widget. And then you can say I want to return a transform rotate. So everything is built in. I didn't do any magic here. I'm not even using anything that was customized by myself. So I'll say max.pi and divide by 180 because this is an angle. So you need to transform your degree to angle with a pi. So this one I need to import Dart math. You will love this library when you start to write Flutter. It will appear in your day-to-day life. And the next thing I want to pass the animation, which is a twin, to this one. So now I have it. I need to do a hot restart. I think something wrong is here. It's not working because I didn't pass a widget. I'm sorry. So in rotate, I need to tell them what widget to rotate, right? So I want it to rotate the child, which is this container, the 3 stars we made just now. And now I didn't start the animation. So in the initial state, in the init state, this is a life cycle to start everything in a stateful widget. So I say animation controller.repeat. This basically means infinite loop of the animation. Let's do a hot restart. Yeah, as you can tell, it starts to rotate. And if you want to compare it with what we achieved on the web, it looks exactly the same. And you can change the curve to linear. So it rotates in a constant speed. Let me restart. And the same here, if I change this to a linear curve, they will rotate in a constant speed together. So because I'm sharing the screen, so the FPS on the mobile emulator doesn't look so good, but on the actual device or in the perform mode, it looks fantastic. So this is a live coding session about the Flutter UI system. So I hope after this, the web developers and front-end engineers are more confident to pick up Flutter because of the ease of transferable skills in the layout system from web. And also for Flutter developers who came from native world, I think you should be confident to pick up Flutter Web and also React, for example, as well, because the layout system are pretty similar across these two systems. And the next thing I want to cover is the state management. So in React, in modern front-end stack, whether it's React or Angular, state management has been pretty matured. So for example, in React, you have the classic one called Redux. So it basically follows the event sorting pattern. You have the single source of truth in a global store. Instead of recording the exact value of some elements, you record the changes, the events that trigger the mutation of your store. So from the graph here, as you can tell, if you don't use a state management tool or Redux, you'll find out there are many interdependency among your elements, among your widgets, which will become a disaster if your app grows big. And if you with something like a Redux or Mobex with a concept called store, you can control what elements should subscribe to the store. Whether it's a React component or Flutter widget, it's the same concept. And also you can have a definition of what events can mutate the store, and all the subscribers will be notified. So the unique part of Redux is that everything is in a single chunk of big store. So you have one single instance. We call it a global store. So, and also you can chain different React actions, chain different events with some utilities middleware called Redux Sunk. It's also available in both React and Flutter. And the next thing is that you have something called a Mobex, which will give you a multi-store, which is slightly different from Redux, but it is still a unidirectional way of flowing your data. So it's trying to tackle the similar problem, but in a more organized way. So some people prefer Mobex as well. It's also available in both React and Flutter. I believe most of the front-end engineers in React already are familiar with these tools. And the next thing is that Flutter released a provider last year. It's something, in my view, is something very similar to the context API from React. So the concept that you have a provider, you have a consumer, and every time when your value in the provider has been changed, all the children who are subscribing or who are consuming this provider will be notified. It's the exactly same thing like React. So you can use them interchangeably in your mental model when you develop Flutter with the provider. And there are something unique in two steps. So in React, our team is highly relying on Redux Saga because it utilizes the stream, it utilizes the generator function, so we can create very complicated use cases like you can have like OTP trigger, just declare it once, and you can use it in every different processes. And to test Redux Saga is pretty easy because it uses generator function. Every step is very predictable. However, in Flutter, there is no Redux Saga. I will talk about why there's a limitation for it, but we have something called a block, business logic component, which is very similar to Redux Saga in certain extent, but I will cover more about the details in the next slides. So this is an example of block in Flutter. So as you can tell, It's used some yield syntax for generator function. Basically, in Flutter, it means it returns a string. And this one will give an event state called activity loading. And in React, on the right-hand side in the yellow box, this is the code of Redux Saga. As you can tell, both of these two implementations are implementing something which is 3 different states of classic API call with a loading state, success state, and a failure state with the generator function. So this is something you can easily transfer from Redux Saga to Block. And what if you want to communicate among your among your resources? In Saga, you can use action channel, which to communicate between different sagas. You can also pass Saga as a parameter to another Saga, so that when you instantiate, you get access to the other sagas in one Saga. A similar thing in Block. If you want to access user block from authentication block, you can pass user block as a parameter to your authentication block. That's one way. Another way is that if your app is getting larger, you want to manage them in a more predictable way. So you can use a library called getit, which is a service locator. It will create a singleton instance when you start your app, so you can access this any blocks anywhere if you put them in this service locator. So we are running out a little bit of time, so I will have 2 more slides to quickly cover. One is state management, that in Redux Saga, we have a concept called tick lattice and tick array. That's one of the side effects. Tick lattice means within the accumulated stream of events, you will cancel all the previous incompleted one. You only care about the latest one. So in Flutter, in Block, by default, it is tick array. It consumes every single event. But if you want to consume only the latest one in your stream, what you can do is you'll use the extension from RxDart, which will add on some new method into your generic stream from Dart. Like for example, in this case, we use switch map. It will drop all the previous incompleted event within the stream, and it will only consume the latest one. And the last thing about state management I want to mention is why there is a limitation to implement Saga within Dart. Because in Dart, the syntax trigger yield is a statement instead of an expression. So in JavaScript, yield is an expression, so it doesn't end a method. It doesn't end an execution. So you can have some return from yield function. You can say my result equals this, and you can continue the execution. However, in Dart, because yield is a statement itself, is like a execution with a return. So you cannot continue your code after you yield. So that's why if you want to have some subsequent logic, you have to use a callback function and pass it to the yield function. So that's why I think in short period of time, Saga won't be available in Dart, because it doesn't make sense to use a lot of callback to do it, because the beautiful part about using generator function is that your code is more readable and maintainable. So internationalization, I will quickly skip that. So internationalization in React is using some AST Babel plugin, transform your code to AST and output the JSON file for the assess of your language. And it has a similar official library supported in Dart as well, developed by Google. You can achieve something similar, and it can generate the art file when you run the generator. I believe underneath it passes the code to AST and output it into an art file. So the last thing I want to cover is ready for production, because Flutter is relatively new for production usage. So we found out CI/CD. There's a good tool called CodeMagic.io, which is a startup for CI/CD. It is dedicated for Flutter CI/CD. So a lot of other box features like sending, connecting to Apple Developer Center, and provisioning, versioning, but it doesn't have a lot of good integration like Bitrise.io. However, it has better support for Flutter compared to Bitrise.io as of now. And the next thing, we use Google Firebase Apps Distribution for beta testers. And they can internally test the app without going through the Google Play Store or Apple App Store. And the next thing, we have Crashlytics and Sentry for reporting of errors or crashes. And we use Google Analytics for behavior tracking and user persona as well. One thing to note is that Mixpanel is pretty powerful for tracking and commonly used in the web, but the SDK is not available in Flutter yet. So I hope Mixpanel will pay some attention to this one and try to draw out a good SDK for us to use. So that's all about my topic today. To wrap up, I hope I gave you a sense of how web development can be easily transferred. How the skills can be transferred to Flutter quickly and be confident for it. And for native developers, I hope you get a sense of how the modern web front-end development inspired Flutter and how the framework are similar and how they are different in certain areas. So lastly and quickly, our app is launching very soon. We are currently on a React web app. If you are willing to try out our platform, you can use this voucher code to sign up. You will get $20 free credit. So thank you. That's all about.
I will use like the power of host and will ask maybe the first question. I'm curious, how much years, how much experience do you have in React Native?
So I only had, as I said in my slides, I only had 5 months of experience in production grade React Native, but I have been on React for about 4 years.
Yeah. How easy was it to switch from React Native to Flutter? Like what
Right. I think it was pretty easy. For example, in my case, I think I got speed up in about 2 months. So I read a book called Flattening in Action, and after that, I didn't digest everything from them. So I just straight away to grab some code, follow some tutorial, and after 2 months, I'm pretty confident and comfortable to build complicated animations, complex layout, and state management as well. So I think the background of React and the state management, modern frontend do help. For me, it was about 2 months to get comfortable.
Alexei is asking, do you use single Redux state for the whole application?
So right now we are using block, as I said. So we did take a look of Redux store, and I think for now we are considering whether MobX continue with the block or switch to MobX. Because one way I found it difficult with the Redux in Flutter is that because Start has this typing system, so if you declare everything in a single global store, to handle the type safety is pretty, it could be challenging. So that's why I would prefer either to continue on block, which the mental model is very close to Redux Saga, or we switch to MobX with the power of ArcStart and the observable stuff. Yeah.
So Johnson is asking, do you have any recommendations for Flutter app testing automation?
Yes, so I think Flutter, I think Google really put amazing effort on this ecosystem. So out of the box, you have this Flutter unit test where you can pump a widget, and it's like a React testing library for web developers. You can mimic the behavior of rendering a widget and try to find some element and do some assertion. And also for CI/CD process, there's a Flutter driver test. So you can utilize Flutter driver. You can deploy your app to like AWS device farm to run your end-to-end tests, for example. Yeah, so most of them are out of the box. And on flutter.dev, the official website, there's a good tutorial about this entire thing.
Okay, thank you. And I think the last question from 171. In terms of security, is Flutter able to have APIs to access Android Key Store and iOS Secure Enclave?
Yes, that's a very good question. I got this asked many times when I choose Flutter. So yes, in the recent development, Flutter support both keychain from iOS and Android Key Store natively. So they have this API, yeah. From official, I think it was from the official team or some community team, but it was pretty mature.
Just let me share one more comment from Sam. I think everyone thanks you. So thank you, John. Hope
Thank you.
to see you next time for the next talk.